For homework 10 problem 2, it needs us to collect the definition of properties of different stochastic process. And the first is a Y-sense stationary process, which we call it WSS. It is a mean that this process, the mean of this process is a constant, and the autocorrelation is a function of the time difference, which is t1 minus t2. And then the second process is the independent increment process. It means that the x1, t1 minus xt2 and x3 minus xt4, if it is non-overlapping, the intervals are independent. Means so far we can know that the Poisson process, the random walk process, and the Wiener process is all independent increment process. Non-overlapping intervals are dependent. So the third process is a Markov process. We know that if the past has no influence on the future, when the present is known, it is a Markov process. And so far we know that the Poisson process, Poisson impulse, semi-random telegraph, random walk, Wiener are all Markov process. It has a property that p x n big x n equals small x n when x n minus 1 equals to x n minus 1, so on and so forth, equals to p x n. So there are no influence on the past with the future. The fourth process is the normal process, which is very familiar with. It has a property like this, the density function, and we can just write it like this. And for each part, the small x represents this one, and the big X represents this one. The fifth process is a strict sense stationary process. We call it SSS. To me, it has the condition of the density of this one equals to when time all adds an atom that Kasai. It is a hard condition to meet with. The sixth process is the white noise. White noise, we got this the conception from the Wiener process, and we get the derivative of Wiener process, and then it is a white noise. But we can expand it to a larger scale, that if the process have the mean of 0 and the autocorrelation equals to qt1 multiple theta t1 minus t2, it is a white noise. This seventh process is a mean ergodic process. From the lecture we got that if the process meets this expression, it is in mean square sense, it is a mean ergodic process. The eighth process is a martingale process. For this process, it has the property that when the x equals to x1, and the expectation of this new process probability is also x to 1, which means that the conditional mean equals the condition. The random walk process and the Wiener process are all martingale process. That's all.